Every implant you place triggers a biologic negotiation. Place it too shallow and the bone will remodel. Place it too deep and you risk inflammation, deep sulci and aesthetic collapse. So what really dictates implant depth? It's not the bone crest, it's the soft tissue thickness. After 30 years in surgery, I've learned that biology drives success. This channel explores implant and oral surgery, how the body responds, how we can improve healing, what the science shows, and how disciplined surgical execution turns evidence into results. Welcome back. The body needs a constant vertical dimension to maintain the soft tissue seal that protects crestal bone. That dimension is about 4 mm from the implant platform to the top of the gingiva. If you understand this one number, you can prevent most cases of early crestal bone loss. The peri-implant biological width is the vertical zone of soft tissue required to establish a stable, protective attachment. It includes the junctional epithelium, which is about 1–1.5 millimeters, connective tissue attachment, which is about 1.5 to 2 millimeters, and together roughly 3 millimeters that forms the actual biologic attachment. Add another millimeter of sulcus depth and you get the clinically necessary 4 millimeter vertical soft tissue envelope. This space is non-negotiable. If it doesn't exist, bone will resorb until the correct dimension is recreated. Multiple studies confirm that the peri-implant mucosa establishes a near constant dimension. Berlung and Linde in 1996 demonstrated that peri-implant mucosa consistently measures around 3 to 4 millimeters vertically. Hermann in 2001 showed that when implants are placed too coronally, bone resorbs until this space is re-established. Linkevicius in 2009 and 2015 and Puisis in 2015 confirmed that the crestal bone stability is directly proportional to the soft tissue thickness. Thin tissues lead to bone remodeling. Thick tissues protect the crest. The conclusion? Biological width is a fixed biologic demand, not a variable design feature. Every implant requires 4 millimeters of vertical dimension from the implant platform to the gingival zenith. The sum of soft tissue thickness plus implant submergence below the bone crest should equal 4 millimeters. If you have, for example, 2 millimeters of soft tissue, place the implant 2 millimeters subcrestally. If you have 3 millimeters of soft tissue, go 1 millimeter subcrestally. If you have more millimeters of soft tissue or more, place the implant crestally or slightly supracrestally if the implant design allows. This ensures that the biologic seal forms completely within soft tissue, not at the expense of the crestal bone. If you place an implant shallow in a thin biotype, the body will resorb bone to recreate this 4 millimeter space. If you bury too deep in thick tissue, the excess sulcus invites inflammation and maintenance issues. The goal is constant. From implant abutment junction to the soft tissue zenith, maintain about 4 millimeters. That's the biologic comfort zone. Bone remains stable, the soft tissue matures properly, and your prosthetic emergence profile remains predictable. The key idea here is implant depth is not arbitrary. You measure the soft tissue, then calculate subcrestal positioning to reach a total biologic vertical dimension of 4 millimeters. This is not a prosthetic preference, it is the immune system's engineering. The body requires a buffer zone to protect bone from bacteria and mechanical stress. If the vertical space is insufficient, the immune system remodels bone downward until stability is achieved. When you anticipate that biologic need by measuring tissue and setting the implant depth accordingly, you prevent the corrective bone loss that so many clinicians mistakenly call normal remodeling. So before your next implant, stop and measure. Check the mucosal thickness. Calculate how deep your platform must sit so that the total vertical envelope equals 4 millimeters. When you respect that number, Bone doesn't move. Biology is satisfied. Measure tissue, set implant depth, protect bone. Because long-term stability begins where biology feels at home. Please like, subscribe, and comment below. Thank you.